look around you for a moment. Your phone, your laptop, even the spoon you used this morning.
They may look completely different, but they all have one thing in common. None of them would exist without metals. But have you ever wondered what makes metal so special? Every object you've just seen relies on one important group of materials, which is metals. From the copper wires that deliver electricity to our homes, to the steel structures that support towering buildings, metals are an essential part of modern life. But their importance goes beyond their appearance or strength. Their unique behavior begins at the atomic level, where a special type of chemical bonding gives them remarkable properties unlike any other material. To understand why metals are so useful, we first need to explore how metallic bonding works.
So, what exactly is metallic bonding? To answer that question, we have to look far beyond what our eyes can see. Let's travel all the way down to the atomic level. Inside a metal, atoms are packed closely together in a regular arrangement called a metallic lattice. Unlike atoms in covalent compounds, metal atoms do not hold onto their outermost electrons very strongly. These outermost electrons, known as valence electrons, become free to move throughout their entire structure and are called delocalized electrons. As these electrons move away from their atoms, the atoms lose electrons and become positive metal ions. These delocalized electrons continue moving freely between these positive ions, creating a sea of electrons surrounding the entire structure. The strong electrostatic attraction between the positive metal ions and the sea of delocalized electrons is known as metallic bonding. This strong attraction holds the metal together and forms a stable structure. It is also responsibility for many of the unique properties of metals, including their strength and their ability to conduct electricity.
Now, we know why metal atoms stay together, but metallic bonding doesn't just hold metals together. It also gives metals some amazing properties. For example, why can metals conduct electricity so well?
One of the most important properties of metal is their ability to conduct electricity. This property is made possible by the delocalized electron within the metallic lattice. In the absence of a power source, these delocalized electrons move randomly throughout the metal. Since their movement has no overall direction, no electric current is produced. However, when a potential difference or voltage is applied across the metal, an electric field is created. This causes the delocalized electrons to drift in the same direction, producing an electric current. Because these electrons are already free to move, metals can conduct electricity efficiently. This is why metals such as copper are widely used in electrical wiring, electronic circuits, and power transmission.
But electricity isn't the only thing metals are good at. Think about this. Why can we bend this without it breaking?
Metals are able to bend or change shape without breaking because of the nature of metallic bonding. When a force is applied, the layers of positive metal ions can slide past one another instead of remaining fixed in place. Although the ions move into new positions, the sea of delocalized electrons continues to surround them. The electrostatic attraction between the positive metal ions and the delocalized electrons is maintained, preventing the metal from breaking apart. This property is known as malleability, which allows metals to be hammered or rolled into thin sheets. Metals can also be stretched into long wires without breaking. This property is called ductility, making metals such as copper ideal for manufacturing electrical cables and wiring.
While metallic bonding explains why metals have free-moving electrons, band theory explains how these electrons behave in different materials.
Every message you send, every assignment you type, every journey you make, And all of these depend on metallic bonding and band theory. Metallic bonding and band theory are more than just scientific concepts learned in the classroom. They help explain why metals are strong, why they conduct electricity efficiently, and why different materials behave differently when used in electronic devices. These principles are applied in countless technologies, from electrical wiring and transportation systems to computers, smartphones, renewable energy, and modern communication. Understanding this concept allows scientists and engineers to develop safer, more efficient, and more advanced materials for everyday life. By studying metallic bonding and band theory, we gain a deeper understanding of how chemistry shapes the technology that powers our world.